Hello! Today we'll be talking about ventilation, evaporation, heating and lighting in a leisure centre that includes a 25-metre pool and a 4,000 square metre floor area. Let's start with ventilation. There is a mechanical ventilation system currently in use in order to control the building's humidity levels, while the main air handling unit, AHU, serves the pool hall. In this week by day with 16-minute interval view, Advisor enabled us to understand consumption patterns. Investigation showed that the fans were left running at a constant on with very poor degrees of control. Findings suggested that a variable speed drive should be used to help control humidity of the pool to ensure that efficient operation. At night, less ventilation is required, and as such, a night mode is required for optimum energy savings. Next, let's look at the evaporation problem in the pool area. Advisor's day by 15-minute viewing option allowed us to see usage as a whole for the main electrical incomer on the site. Through the site investigation, we found evaporation is a potential major concern. By trying to maintain high pool temperatures, high levels of evaporation were occurring. This is also causing excessive usage of ventilation to control humidity levels both day and night, as seen in the graph. Previously, there was no pool cover installed, even though a pool cover effectively reduces the heat required to maintain temperatures and dramatically reduces the evaporation and ventilation requirements. This purchase can save up to 35,000 kilowatt hours and 6,500 kilograms of CO2 a year, and that's the equivalent of 42,000 euro per year. Now let's talk about the overall heating and boiler system. Before we came to this site was not using a combined heat and power CHP system. Using both monthly view and daily 15-minute view on Advisor, we were able to see that the CHP system will be of major benefit due to constant demand for both electricity and heat. This system will provide enough thermal load to support circuits such as pool, water heater, air heating and other hot water heating on site. The CHP system should work with a high efficiency, low temperature, hot water type system. Compared with the cost of running the CHP, an estimated savings of electrical and thermal output is 30,000 euro, which could also save approximately 130,000 kilograms of CO2. The projected payback time of less than 5 years makes this a hugely worthwhile project to invest in. While we are talking about heat, it's important to mention heat recovery. Plate heat exchangers were recommended for installation into the AHUs. These consist of simple air-to-air heat exchangers that operate on the basis of hot extract airs warming metal plate, which in turn warms incoming air supply. The potential thermal load saved is approximately 42,000 euro with an approximate payback of less than 1 year. Finally, let's talk about internal lighting. Advisor's day by 15 minutes showed that there was a constant need for lighting between the hours of 6 AM and 10 PM, as there was a constant load throughout the day with little variance. Therefore, a proposed upgrade to T16 linear fluorescent lamps was recommended. This switch could save approximately 1,400 euro annually, giving a projected payback of less than 2 years. Although it would be pricier, another lighting solution would have been to make the use of natural daylight and expand the exterior window sizes.